everyone, and welcome to Research Meets Open Source. My name is Serena, and joining us today, we have Ige and Anastasio, who will be presenting their topic on breaking barriers with Eclipse Thingweb and NEPHELE. If you have any questions for Ige or Anastasio as we move through today's presentation, feel free to ask them in the chat or in the Ask a Questions tab. Without any further delay, Ige, over to you.
Thank you, Serena. So welcome everyone, also from my side. So I'm Ege, and I work at Siemens. And today it will be not so much about Siemens, but what we do for the open source. And I will be introducing the Eclipse Thingweb project, which allows us to build interoperable IoT solutions at scale with the W3C Web of Things standards. Yeah, so at Siemens, we contribute to three areas that are relevant today. So standardization, open source, and research. And more specifically, we contribute to the Web of Things at the W3C, so where all the web standards are standardized. At the same time, we contribute to the Thingweb project at the Eclipse Foundation. And also, we are part of the NEPHELE project in the EU research landscape that Anastasios will be talking as well. So I will be focusing on the first two parts, and we'll see that the Web of Things will be a bridge between our two talks with Tassos. Yeah, so the name Thingweb, it's basically coming from two words, so thing and web. So a web thing and Web of Things. So what is Web of Things in the first place? And Web of Things is basically a family of W3C standards that are royalty-free and open to use, including all of the meeting minutes that you can follow online. It is developer-friendly. It's one of our most important focus points, and which allows us to have market adoption on one side, at the same time open source adoption, where we see multiple open source projects. Eclipse Thingweb will be one of them. And in the end, the whole idea is about having reusable API descriptions for everything around us, so every IoT device. And it's not just talk, it's not just some standards. We actually meet together, we hack stuff together, whether they are cars, small DIY boards, or some building automation systems like you're seeing here. And it's a global standardization activity, so we make sure that our assumptions are validated. And Web of Things is not a protocol, so it's not about creating a new protocol. It's basically, the whole goal is to bridge the network protocols we have, which are plenty of, to the different applications. And to do that, we are basically binding these protocols to the affordances, so the types of interactions, where we can also add semantics on top. And this is what we call the thing description. And if you look at it, basically, the goal is to address multiple protocols like HTTP, MQTT, OPC UA, BACnet, different security mechanisms, and so on and so forth with the thing description, so that you can have an easier time building applications on top, where the real value is. The core specification, like I mentioned, is a thing description, or just called TD. And it's basically built on some building blocks. So first of all, we really want to express the effect in the real world. So properties, actions, and events of the device are contained in a thing description. Then with the forms, so we really go into the concrete protocol details, so you can specify exactly what a user of this device should create the protocol messages. And then we can add further knowledge to this TD with the semantic annotation. So there you can really bring your domain knowledge. And all of this is not just some like little boxes on a slide set. You can actually serialize it into JSON LD, which is basically like a JSON format, which allows us to add the semantic annotations. And there you can really see concrete endpoints of the device. Like here we see in CoApp with some relative resources. And in the end, since it is serialized, this document can be discovered and used by the clients, or also what we call consumers in the Web of Things. As I said, it is a standard, so you can just Google for it, and you should be able to see the standard quickly. The latest version has been announced 6 months ago or so in December. where we stayed backwards compatible to the 1.0 version. And so I will show a bit the details of a TD so that we get a bit of a context what we're talking about. If you have followed anything like OpenAPI, Async API, or similar concepts, I think what you'll see here will be quite familiar. Yeah, so with a thing description, we start at the top level. So this is when you see a TD at the top level, you will see this kind of keywords, so to say. And what we see here are metadata information, so anything that you need for your applications like title, ID, and so on and so forth. We can incorporate security metadata, so what kind of credentials would you need if you want to really access this device. We can, as I mentioned, annotate it further to really give more context into what this thing is, to have common understanding of the capabilities of the device. And then we can go into the concrete affordances, so like what this device really offers us, so that we can really influence the real world and what we can get from the real world. If a TD is not enough, we can also go and extend it, so we can add links to other documents. So if you want, you can put documentation web pages, or I don't know, a UI of the thing, you can link it all. But the TD itself focuses more on the interaction affordances. So when we get into it, interaction affordances are basically called properties, actions, events. So properties are things like temperature, actions are more like a real function of the device, and events are basically emitted asynchronously by the device. In all of them, we can again add further metadata if you want to. Then we are using JSON schema. So if you want to describe your payload, you can do so with the JSON schema. And you can be as specific as you want to define any kind of complex payload schemes as you want, and so on and so forth. And what is more important is that it's not just some abstract concepts. We can actually really get into the protocols. And when we do so, here we are seeing a bit more cryptic stuff, so to say. And the first part is that we identify the protocol that we want, that the thing has, and the different URIs. So just for example, we can have one form with an HTTP and another one with MQTT. Then we can add our operations. So this is what you really want from the application level. So you say, I want to read a property. So let's say temperature or current of the device. And that way you can really abstract away from the protocols. And then you can add the concrete protocol vocabulary so that your driver really knows what to send. So in this case, it knows the exact MQTT topic to subscribe or the exact HTTP method to send. So what can you do with it? So it's nice to write those things, but you should do something with it if you are using the Web of Things. So first and foremost, you should think of communicating with the thing. So that's where you can build your applications. You can do things like you can proxy the device. So you can have, I don't know, a Modbus protocol or any kind of protocol in your local network, and you can proxy it to something like HTTP. You can generate UI, so it is easier to interact with the device. This is all possible just from the TD itself. You can manage your devices, since you now know what all these devices are in some file formats. You know exactly what you can do with the device. And in the end, you can build your business or application logic. So if you want to control the temperature, you can read the temperature property and invoke an action to turn off a heater, for example. And all of these are enabled as well by the Thingweb components, and we will be coming to that very shortly. So if you look into the Web of Things, you will see some other specifications that sort of patch the other areas that you need to think of when you are building an application. So the architecture, you can always use it for having a common reference to different terminologies and how the different building blocks are structured with respect to each other. With discovery, that's how you can basically find TDs in a network, like in a local network with things like DNS and so on. Or you can have a standardized REST API to manage thing descriptions. With the profile, which is an upcoming one, it allows us to constrain the TD, so it's easier to implement it in certain use cases. And as I've shown with these bindings, so to the protocols, we can really talk about concrete protocols, and these are written by so anyone who's an expert of the protocol. so that we really cover those domains. And then we have the scripting API, which we will get into today, and the use cases and requirements. So there you can find what people are doing with the Web of Things and be inspired. Yeah, so with this, that was the first part of my agenda. And so I think I'm done with the Web of Things. And now we can get into what the Eclipse Thingweb allows you to do and what its goal is, and what we have other than the Thingweb inside the Eclipse Foundation. Right, so Thingweb, as I said, it's about the Web of Things, and it's basically to offer components so that you can make IoT solutions interoperable at scale by leveraging the W3C Web of Things standards. And this is valid for improving an existing solution or building a new one from scratch. So you can take one component that would fit your architecture and forget about the rest. Yeah, so what are components? So basically with the components, you can describe the devices. So that is basically where the TD is, and that's what all of our components are using. You can integrate the devices, so you can build some connectivity solution using the IoT protocol, but using a single uniform interface, so programming interface. You can basically validate and manage the device descriptions, so that it's consistent, and you can basically do so across multiple directories of devices or different deployments. And you can then develop applications, so using a runtime which will allow you to build these applications in a simple fashion. Yeah, so I will then talk about some of our components. And I'll start with the primary one that speeds up the process the most. And with Node.what, so it's Node Web of Things, we offer a way to set up IoT applications with the thing descriptions. So this is also the reference implementation of the scripting API that I briefly mentioned before. And it's written in TypeScript. And that means you can also take the code and use it in browser environments. And you can have it as an npm dependency, or just use it as a standalone application with a CLI. And it supports multiple protocols. So that way we can attract different domains. So meaning that we can have things like CoAP, HTTP, MBus, Modbus, MQTT, Opus UA, and you can add just more if you want. There is nobody, we welcome our other protocols, and they can even live in your own repositories. And that's how a real code looks like. So it looks simple, and that's the goal of Node.what and the scripting API. As you can see here, we are basically working with thing descriptions, and as soon as you basically get a thing description, you have a software object that you can use to act on the real world. And you can really read temperature values, for example, and then act on it. So if you see that there's an overheat event triggered, then you can go and turn off the controller. And we really have network messages happening here. So basically, this is a little interface that we provide. And then underneath, inside our runtime, this read property function call is transformed to, for example, Modbus, HTTP, MQTT, Opus UA, or more. But in the end, they all look the same to the developer. So basically, we get rid of all of this protocol complexity thanks to this little abstraction layer without changing anything actually in the devices themselves. Yeah, so if you look into some of the highlights of the last couple years of Node.what, we have reached a status where we can have monthly releases on NPM. So it's becoming much more mature. And it is getting commercial adoption, of course, that we know of. Maybe there are more. But for example, a company in Germany is using the Node.what for their MQTT binding. Is using MQTT binding of Node.what for the digital twin products they are building. And there is a video of it available. Of course, I can share the slides later. And Vimy is building monitoring solutions So a startup in Italy, for example, for voltage transformers or agritech scenarios, and they have a live demo online. Similarly, Fraunhofer IAS, so a research institute in Germany, has set up set up at the Munich airport, and they are basically scanning more than 2,000 luggages per day. And it's also, again, documented with their video, so you can really see not what in real-life scenarios. Additionally, we from Siemens, we also used it in the last Hanover fair. So in the end of April, if you were there, you could have seen it under the hood in some of our demos. So basically, what you can see in all of these is that people are using NodeWatt to build something bigger than just NodeWatt. So it's not the end goal to use NodeWatt, but it's to actually integrate it into your own solutions. And lastly, we had a nice, real open source moment. So we have a new, basically, way of using NodeWatt, and you can now use the inside Node-RED, which is a low-code programming environment, also open source and under the Linux Foundation. And the NodeWatt inside Node-RED allows you to basically, not even code anything, but just use these blocks and just put them together like this, so that you can build your own stuff in Node-RED. So that way you can just read a property or just log it and put it into a dashboard. But a nice other thing is that you can let the Thingweb do it for you. So you can just paste the thing description, then NodeWatt automatically generates the flow with the different dashboard elements, and then automatically creates a dashboard as well to you. So it's, of course, a very basic one, but it just works, and it will work for any protocol that NodeWatt supports. Right, and with this, NodeWatt is over, and now to the playground. Playground is another component which allows to validate and manipulate thing descriptions. So it can be used, again, as standalone packages, a CLI, or a web interface. At playground.thingweb.io, you can find the web UI. And you can see a basic instance of it. It's quite simple in the concept. You can just paste the thing description and then get some results out of it, whether it's validation or, like you can see here, you can convert it to other formats. So if you have an HTTP device, you can get an OpenAPI representation out of it. If you have something like MQTT, you can get async API. And for the other ones, I'll get into it, so which is where we have the connection to the other projects. At the same time, we are offering publicly reachable things. So at the Plugfest Thingweb.io, you can see a list of the devices that we have, and they are, of course, just simulation instances, but there you can just test your usage of HTTP CoAP, MQTT, and soon there will be also Modbus in public internet. And that way you can really test your own stack, so it doesn't have to be even a Thingweb component that you're testing, but you can just go ahead. A latest one that is also available now with the addition of Dartwatt is also our message to show that it's not just TypeScript or browser stuff, but we can really think of other programming languages. So it's basically a Dart-based TD consumer. It has been modeled after NodeWatt, and basically, it's a new component, as I said, and basically allows, again, different protocol supports like HTTP CoAP and MQTT. And the interesting part is that you can actually now use it for building mobile applications. So you can put it into something like Flutter and then get, basically support for these different protocols using thing description in your mobile application. And the last one is the thing description directory that we have. So this discovery specification I mentioned before, we have an implementation of it in Thingweb, the Domos TD directory API, where basically you can build a home for your thing descriptions. And it's exactly following the what discovery standardization, and it's a Python-based component. So the API is implemented in Flask, and it exposes the different endpoints, including Sparkle endpoints, and you can actually switch the database as you see fit. So you can use different databases from other providers as you wish, as long as they follow the Sparkle standards. And importantly, it allows to do semantic queries, so you can be very expressive on how you build your queries. And a nice other addition that we have is that you can extend it with the Flask blueprints. So you can trigger some own endpoints, so it doesn't have to be just limited to the discovery spec. So you can think of other standards like that are tied to the TD, or you can transform documents on the fly, or you can do framing via JSON-LD and so on and so forth. Yeah, so with this, a little bit of a roadmap, since Thingweb is an ongoing project and actually quite a lot has happened since maybe about 1 year. So we did a big refactoring of everything. So we have many new components, regular calls, new project leads, and we have more evidence of the commercial adoption and more stability. With this, we also have new things in the horizon. So we are planning for more modularization of the tools so that you can use each of these individual building blocks, just those ones in your own applications. We also planning some interoperability tests. We do some basic ones, but not very thorough and not very documented. Also, we are planning a new website with a kick-ass landing and documentation for each component, and hopefully more that we can just host there, so that we can really convey the image of Thingweb better for everyone. Yeah, and one last point about the collaboration. And so on the left-hand side, we have the Web of Things. As I mentioned, we have the Thingweb implementing the Web of Things standards. And on the other side, we have the AAS, so the Asset Administration Shell, getting more and more popular in this Industry 4.0 domain. And basically, there is a love child, so the AID. So the Web of Things is possible to be used inside the AES environments, thanks to this asset interface description. And it's not at a W3C or anything, so it's happening at the IDTA, so Industrial Digital Twin. And basically, it follows the what thing description so that we can onboard these kind of devices to the asset administration shell. And it's again like TD. It basically describes an asset, and what you can see here is using one of the UIs for asset administration shell, which is also a part of the Eclipse Digital Twin project. And then you can really go and see the details, and this is basically a thing description in here. So that means you can have the synergy between the different projects thanks to the thing description. And with the Thingweb, we of course have the support for it, so you can actually just convert an AID into a thing description and just use it the same way you are used to. And then you can really read live data of the device. Right, and when we look at the other friends of the Web of Things, we also have on one side the editor, which is an advanced TD editor where you can just work with like buttons and so on to create a thing description or thing model. And at the same time, the Eclipse Ditto, which is rather established project, and it has a Web of Things integration since release 2.4. They are already in, I think, 3 point something these days. So they have been using TD for quite some time. So in the end, all of these are just means to an end. They are just building blocks. So you should go ahead and use them to build your own solution. And we are excited to see what you can do with it. Yeah, if you want, you can learn more about the Web of Things and Thingweb at the website. So the W3C website has everything about the Web of Things and other open source tools. And on the other hand, the Thingweb website has the link to all of our components. So you can just go to thingweb.io and find everything you need about Eclipse Thingweb. And one last thing we should never forget, but thank you to all the Eclipse Thingweb committers and contributors over the years. So of course, it's a project with multiple people. And what you're seeing here is just a small part of everybody who contributes. On GitHub, we have an even bigger list of contributors that are doing amazing stuff. So thank you all. And with this, that's the end of my presentation. So if anybody wants to follow up on some of the links, I put the QR codes here, and I am also open for questions. Well, we do the questions at the end, so thank you.
Nice. So, thank you, Ege, for this presentation. I think I can try to also take over and share my screen. Okay, nice. Hope you can see the screen. I will follow up with a presentation made by Ege and also show how outcomes coming from the open source community and the Web of Things working group can be very useful and be used within research projects. So just to introduce myself, my name is Anastasios Zafiropoulos. I'm a postdoc researcher in the Network Management and Optimal Design Laboratory of the School of Electrical and Computer Engineering in the National Technical University of Athens. And we are coordinating the NEPHELE project, that is a research and innovation project where we focus a lot on the development of open source tools to facilitate convergence of IoT, edge, and cloud computing technologies. And I will try to show an overview of our activities within this presentation. So just as a very, very short introduction to NEPHELE, we have two main challenges. Okay, so in this slide on the right part, I have shared a figure coming from a white paper from Eclipse Foundation, where we can see different type of open source solutions related to development and management orchestration solutions within the edge to cloud domain. And as you see, there is a plethora of solutions out there. However, let's say each one of them tackles one part of the challenges about convergence and orchestration. So in NEPHELE, we come and we try as much as possible to homogenize some of the work out there and tackle convergence and interoperability challenges a little more. So we have two main innovations, two main challenges to tackle. The one is the convergence of IoT technologies. So we work a lot on IoT interoperability. And the other is the provision of a meta-orchestration framework where we can manage deployment of distributed applications over resources that span across what we call the computing continuum. So on one hand, we have the need to support interoperability with different type of IoT devices and technologies. And on the other hand, to manage to bring the IoT domain closer to application developers that develop applications for the edge and cloud and make them orchestratable in a unified way through proper tools. And okay, when speaking about the computing continuum, we refer to resources that span from the IoT to the edge to the cloud part. So you have a high notion of distribution in the way that you manage applications. So under this perspective, in NEPHELE, we offer two main artifacts. The first one is an open source IoT and edge computing software stack. I will show details. It's called VioStack from the notion of a virtual object that we will introduce. And the second one is a synergetic meta-orchestration framework that builds upon this stack to manage orchestration of distributed applications. And both implementations are provided as open source and are maintained under the GitLab repository of Eclipse Research Lab. So we try and we foresee to build a community around it and to make these solutions available to any interested part, both for contributions, but also for adoption and extension in the future. So just to highlight that moving to open source within a research and innovation project, for us, it's a strategic decision. We want to promote the results and to increase their uptake by, first of all, developers, but also other adopters in the industry. We try to build upon it and create a community considering the partners that contribute within the project, but also partners that come into the project through open calls, and also any interested partner outside of the project. And we try also to have very close interaction with standardization initiatives and working groups, including the Web of Things community that we have adopted the solution, and we have tried to work and to provide, let's say, to work incrementally to provide some add-ons coming from our perspective, so from NEPHELE. So everything is under Eclipse Research Labs GitLab and accessible live repos that we try to work on and maintain. Now, some highlights of our approach. In NEPHELE, we have adopted a system of systems approach in orchestration. So we consider applications consisted of many microservices, so a lot of complexity in their management. And we try to follow an approach, an hierarchical approach, where, let's say, the upper node is responsible for the overall deployment of the different nodes. However, the control is distributed in many different entities, that each one of them can take some local decision making, and where needed, ask from the upper level of the hierarchy for support for more global decision making. So all our solutions are under this main principle of system of systems. So we try to introduce automation and intelligence, taking advantage of this way of interaction among the entities. Now, in the lower part, where we have the Internet of Things part, we try to work on virtualization of IoT devices. So we have introduced the notion of the virtual object that is very close to the notion of the virtual thing in the Web of Things community. And we consider that each IoT device has a virtual counterpart mentioned as virtual object that can be deployed in the edge part of the infrastructure. And around this notion, we are building a software stack. It's called Virtual Object Stack. It's an open source software stack that aims to support functionalities for the operation and lifecycle management of virtual objects and their functions. And moving one step further, we have introduced the notion of composite virtual objects that actually can interconnect more than one virtual object. We mention them as VOs, more than one VOs, to provide advanced information and functionality, or a composite virtual object, mentioned also as CVO, okay, in short, can enhance the functionality of just one VO. So it can also act as a digital twin in many cases. So in a visual way, we have different types of devices. It can be one device, it can be a cluster of devices. We have their virtual counterparts in the edge part of the infrastructure, called as VOs. We can interact with different communication protocols. Over them, we have composite VOs that can interact with one or more VOs, can also undertake the role of digital twin. And these VOs and CVOs are interoperable through specific interfaces with distributed applications composed of microservices. So at the end, we have interoperability with different types of IoT technologies, and also convergence with edge and cloud computing technologies. So this is one of the main contributions of NEPHELE, including, not mentioned in this figure, but including also semantic interoperability aspects. So we have developed a specific software stack. It's called the virtual object stack. We have three main layers. The physical convergence layer that tackles interoperability and communication with the IO devices, including security aspects. The backend logic layer where we introduce intelligence in terms of different type of functions, virtual functions that can be supported by the VOs and CVOs. And the edge and cloud convergence layer where we consider orchestration interfaces where the VOs and CVOs can be manageable by edge and cloud computing orchestrators, but also we tackle semantic interoperability aspects, translation between different semantic models to make the data available to developers in a way that it can be easily managed, and also multi-tenancy aspects where you have different tenants collaborating with one or more of the VOs and CVOs. In a more granular, let's say, schema, these layers are broken down in more functionalities. And also, in some cases, we try to introduce extra functionalities in the form of sidecars, specifically for enforcement of specific security schemes to manage the interaction between the various components of VOs and CVOs. Time-sensitive networking functionalities where we have specific constraints in terms of latency, and also software-defined networking functionality. So we try to have add-ons that can be applicable in a modular way, depending on the scenario that we want to support. And also to mention that in the upper part, we work on semantic interoperability aspects. So as considering modeling works around W3C Web of Things, Open Mobile Alliance, LWMTM, and NGSI-LD models. As a highlight to mention that the implementation of VOStack, we have versions that are aligned with the implementation mentioned by Ege in the previous presentation about W3C Web of Things, and we try to have a close interaction with this working group, and we thank a lot the colleagues that manage the group and the contributors there, because they have supported us a lot to evolve our solution, and it was a great starting point for us to start from the implementation of the Web of Things and move to additions in VOStack. And we have also implementation that is also aligned with Open Mobile Alliance lightweight M2M, that once again, there was an initial implementation available from the colleagues in the consortium, coming by CNIT, and that we also maintain and we try to evolve. And for sure support interoperability in the different type of implementations. So, as a highlight, our solution is contributed also to the developer resources of the Web of Things community, and it's called VOWOD. So it's a Python-based implementation. So it's available under the repo of the developer resources, and we have also provided access to software and documentation, so how someone can use this VOStack. And I would also like to highlight that through the open calls, we try to extend this to the community so as to get extra implementations of specific VOs, CVOs, and digital twins in different vertical sectors, as well as extend the functionalities of the virtual object stack. So we try, in addition to the vertical areas that we consider within NEPHELE, to try to expand and validate the approach in various verticals, and also examine potential exploitation pathways. Now, considering the development of the virtual object stack, in the project, we work a lot also on the orchestration aspect. So I will do a short presentation, some slides about this part. We have different types of stakeholders I won't go into detail, but we consider providers, infrastructure providers, and application service providers on this part. We have followed again standardized methodology for the specification of the architectural work within NEPHELE, considering the specification of viewpoints based on specific ISO standards. And we have come up with an NEPHELE architecture where we manage the deployment of and orchestration of application graphs that can combine application components, virtual objects, and composite virtual objects. And in these application graphs, we consider that we may have the need to manage graphs with specific type of requirements, properties, and constraints that have to be assured and respected during deployment and runtime. So we come up with the need to deploy such application graphs over multi-cluster infrastructure, taking into account the detailed requirements. And so we have specific deployment schemes that consider the defined requirements and the constraints, and they are translated to deployment plans. And we are following on this, we are following an intent-based orchestration approach. So someone can declare in a high-level intent what wants to achieve in the deployment. And this intent has to be translated into a deployment plan, applied over the infrastructure, monitored, validated, and we can have a continuous learning process here so as to see how a high-level intent, so high-level objectives, can be fulfilled or not during the deployment. So for the orchestration part, we have come up with a solution, a reference architecture, and the implementation of a relevant orchestration platform that is open source, and also a development environment. So we have an open source version of a development environment where developers can use to introduce their software artifacts in a specific repository. And through a dashboard, this can be led to deployment over what we call a synergetic meta-orchestrator. The synergetic meta-orchestrator manages the deployment of distributed applications over resources in the computing continuum. And two of the main components of this orchestrator regard the multi-cluster resource manager. So you may have different compute resources, different clusters, from the IoT to the edge to the cloud part. But you can also have a network resource manager, and this to collaborate. So you can have management also of the network flows that have to be established in this infrastructure. And in the applications that we consider, we have also integration of VOs and CVOs coming from the virtual object stack. I'm not going to go into detail. However, we have modeled the different type of interaction between the different components in the orchestration business logic, considering the various resources that have to be managed in the compute and network part. And it is work in progress, but we have a first release of the NEPHELE platform, orchestration platform, that is again, released as open source, that you can introduce your applications, manage the deployments over multi-cluster infrastructure, have real-time monitoring feeds for what's going on in the deployment, and get access to this information. And currently, we focus a lot on the development of the injection of intelligence, so the development of orchestration mechanisms, considering AI-assisted orchestration and schemes that we have collaborative AI mechanisms, so different AI agents deployed in the various parts of the infrastructure that they collaborate, and they can lead to intelligent decision making in the various levels, whether they are in a global level or in a local part of the resources. So we work a lot on such mechanisms over the computing continuum, or what we call in some cases distributed computing continuum. Part of them has to do with autoscaling. So we work a lot with reinforcement learning driven autoscaling. So we train the agents to learn and to take decisions when the application components have to scale. So we reduce this burden from the administrators of the infrastructure, and we try to do it in the intent-driven way. So a high-level objective is translated to specific SLA guarantees, and then the agents are responsible to undertake actions so as to optimally scale the available application components. And we have seen that based on this, we can achieve increased efficiency and the reduction of the SLA violations in the deployments plan. So there are relevant publications produced for this. And all these solutions are validated in different use cases, considering within the project emergency and disaster recovery scenarios, remote healthcare scenarios, smart logistic operations in ports, and energy management in smart buildings, where in all cases we see what does it make sense to be virtualized in terms of virtual IoT resources, taking advantage of the virtual object stack, and what kind of intelligence orchestration mechanisms have to be applied to facilitate the operation and the provision of the applications. And that's all also from the NEPHELE part. As a highlight, just also to recap that we focus on open source. We try to build in addition to existing solutions, so take advantage of a lot of work that is already out there, try to be complementary, and have some added value on this. And part of this is also related to the first presentation, the solutions coming from Web of Things, and that is one of the main artifacts considered in VioStack. Thank you a lot for the attention, and I think we can leave some time for some questions and discussion.
Perfect. Thank you both so much, Ige and Anastasio, for the excellent presentation. Just a quick reminder, as we do this wrap up here in the audience, if there's any final questions, feel free to ask them in the chat or use the Ask a Questions tab. So we are also looking to book some more Research Meets Open Source webinars. If you're interested in presenting, please feel free to fill out the form that I'll link in a few moments in the chat. And lastly, we have some very, very exciting news. So Open Community Experience 2024 is the Eclipse Foundation's flagship developer conference. So join us at our global ecosystem that gathers on October 22nd to 24th in Mainz, Germany. The call for papers is officially open, so kindly click also on the second link that I'll provide you momentarily to submit your talks if you are interested. All right, so let's just go and take a quick look now and see if we have any questions. So we have okay, you've shared your presentations on your slides. Thank you for doing that. And we have the first question. Can you give an example of the intent?
Thanks. I think it goes mostly on the part of the NEPHELE presentation. If I can very shortly again share maybe the slide, maybe it will help a little to provide an accurate response. Okay, so we are working on a way that we can define a formal way of describing the intent. However, it actually is a collection of requirements, properties, and restrictions that the idea is someone can declare these requirements during design time. So if you are an application provider or an application developer and you know that in this link between application component 1 and 2, you want to have very low latency because the decision making there is latency sensitive. You can declare this as a kind of metadata in your application graph in a YAML descriptor. You can also say that component 5 needs to have a secure access. So this is also an intent that maybe later on be translated to the deployment of a firewall between 2 and 5. Or another intent coming from the data privacy, let's say, domain could be that components 3 and 4 have to be deployed in the same location because their data have to be exchanged among them in the same location, not travel across the internet. So these kind of ways are a potential way to describe the intent. And these descriptions have to be considered by the orchestrator during deployment time and be respected so as to enforce proper deployment plans. This is work in progress, and as we move on with the project, we will for sure offer the overall solution and make it available. Hope I managed to give a reply, but if not, we can follow up or contact me also via email.
Yeah.
Perfect. And then we have a second question from Marco. Ige, like for AAS, is there also some kind of relation to data spaces? Example, Eclipse data space components.
Actually, within a project, research project, I worked quite a lot with the Eclipse data connector. And we actually really looked into some relationships and to see whether the EDC, specifically that EDC, would be binding in the Web of Things. But my initial research, says no at this point because the type of data exchanged is quite different. So what the EDC was quite slow for data exchange because we were not really this whole mechanism of managing the data access and contract negotiation and so on was a bit slow. What is there quite interesting for me is overall access to the thing description itself, whether that would be regulated by something like the EDC. That would be interesting, but that wasn't that much relevant. But overall, for the whole data space, not necessarily within Eclipse, the latest thing I shown the slides of the Fraunhofer show, like using Node-RED in Munich Airport. So they have used solid pods, which also are, for me, an enabler of data spaces. So that was one thing. And also there are lately discussions on basically using AES for data spaces. So there, I think there could be some new stuff happening. So I think this whole area is quite dynamic at this point. And I think we should consider it more seriously. Yeah. But nothing very concrete at this stage.
Okay, perfect. Well, thank you both so much again for your time today. Great presentations. And yeah, I think this is it. I think we are all wrapped up for this webinar. Thank you again and have yourselves a wonderful day.
Yeah, thank you for hosting.
Thank you.